In the heart of Central Africa, where rivers carve through dense forests, something deadly emerged from the shadows. This is the story of humanity's encounter with one of the most lethal pathogens known to science, a virus that would become synonymous with fear itself. In the depths of Africa's equatorial belt, a silent and merciless killer emerged from the shadows, a disease so lethal that it could turn a thriving community into a ghost town within weeks. It had no name, no known origin. But when the bodies began to pile up, the whispers from the morgue told a tale of horror and desperation. This is the story of Ebola. This is the River of Death. The year was 1976. In two remote locations along the Ebola River, in Sara, Sudan, and Yambuku, Zaire, an unknown fever was stirring, a silent, invisible killer, and gripped entire villages. Victims collapsed in pools of their own blood, their bodies ravaged by an invisible force. The symptoms were terrifying: fever, vomiting, uncontrollable bleeding. The mortality rate, up to 90%. The world had never seen anything like it before. And the worst part? No one knew how it was spreading. In the remote villages along the Ebola River, something was stirring, a silent, invisible killer. Imagine a disease so potent that it spreads before you even recognize it. The nurses and doctors tending to the sick were dying as quickly as their patients. It wasn't airborne, so how was it spreading? The answer lay in human touch: fluids, blood, sweat, even the tears of the infected. What makes viruses like Ebola particularly dangerous is their simplicity. They're not even technically alive, just genetic material wrapped in protein, hijacking our cells to replicate. And this one moves fast. Thousands of miles away in Belgium, a team of virologists received a strange package. A blue thermos wrapped tightly with masking tape, labeled simply as "for research." Inside, on dry ice, were blood samples from sick nuns in Zaire. Among those researchers was a young scientist named Dr. Peter Piot, who had no idea that he was about to face one of the deadliest pathogens known to humankind. At first, they suspected Lassa fever, another viral hemorrhagic fever known to cause internal bleeding. But what they found was something far more sinister. Under an electron microscope, the virus revealed itself, a long, thread-like structure, unlike any pathogen they had seen before. A new virus had emerged, and it needed a name. To avoid stigmatizing Yambuku, the town where the outbreak began, the scientists named the virus after a nearby river, Ebola. But identifying it was only the beginning. The real challenge was understanding how it spread and stopping it before it wiped out entire communities. When Dr. Piot's team arrived in Zaire, they were met with chaos. Local health worker: "We had one radio for the entire village. When someone got sick, sometimes it would take days for anyone from the outside to know. The hospital was abandoned. Bodies lay in huts, untouched, as villagers feared going near the sick. Traditional burial practices, washing and touching the dead, were fueling the spread of the virus. And with no protective suits, no antiviral treatments, and only limited knowledge, the scientists had to work under extreme conditions. The forensic investigators were like hunters tracking an invisible predator, following a trail of cellular destruction to identify their quarry. The bodies told a grim tale: internal organs liquefied, blood vessels ruptured, the virus attacking every system with merciless efficiency. And because there was no structured reporting system, no one knew the true scale of death. Dr. Piot's team made a crucial discovery. Most cases traced back to a single hospital where nurses had been reusing syringes, unknowingly spreading the virus from patient to patient. By shutting down the hospital, limiting movement, and changing burial practices, they stopped the outbreak from spreading further. But at a terrible cost. More than 280 people had already died. Ebola is a monster in miniature, a filamentous virus. It invades the body, hijacking cells and turning them into factories of death. It attacks the immune system, causing it to turn on itself. The result is a gruesome, often fatal cascade of symptoms. Dr. Piot would go on to become a leader in global virology forensic investigator. But his journey with Ebola was far from over. This was only the beginning of a battle that would resurface time and time again. Today's AI systems can process satellite imagery, climate data, and animal migration patterns to predict where the next outbreak might occur, sometimes months in advance. Today, we are not defenseless. Artificial intelligence is rewriting the rules of outbreak response. Imagine an AI-driven system that detects abnormal symptom reports in real time, alerting health authorities before an epidemic takes root. Imagine drones delivering medical supplies to quarantined areas, reducing human exposure. This is no longer science fiction. It is our reality. We now have the tools to predict and prevent, but only if we use them wisely. Ebola showed us what happens when we are unprepared. But with AI, rapid diagnostics, and global cooperation, we may finally turn the tide against pandemics. The story of Ebola is not just about a virus, but about humanity's ongoing battle to understand, predict, and overcome deadly diseases. With each outbreak, we learn more. And now, with artificial intelligence as our ally, we're finally beginning to turn the tide in this ancient struggle between humans and the microscopic threats that have shaped our history. The whispers from the morgue tell us many things. They tell us of lives lost, battles fought, viruses plus bacteria live among us, and lessons learned too late. But they also tell us that knowledge is power, that science, medicine, and technology can rewrite fate. Join us. Create your own no-code, Blue Chronic and New Symptoms Tracker calculator with our prompt in the description of the latest AI, no-code tools like Google Gemini, Google Notebook LM, Claude, etc. Report unusual symptoms. Support AI-driven pathogen surveillance programs in vulnerable regions. Fund training for the next generation of disease detectives. Absolutely no AI virus chatbots are encouraged to be created.